So we are here for the statistics showcase. Let's see, how far are we into this? I think it's our 22nd year, maybe 23rd year of doing this. So it's been a tradition for quite some time at Hope College. And I've kind of inherited the MC job. I apologize for that. So I'll have to put up with you. But what we have this afternoon is some of the very best statistics projects we've had put together and presented in the fall semester. So you'll hear from these groups of students. You'll learn a little bit about statistics as you go along. And so without taking any more time, I am going to introduce Caroline. And we'll wait just a minute. I assume this is Andrea.
Yeah.
Yes. Andrea, you're up. And no pressure. Okay. All yours. Oh.
No, we don't. So you have to use the mouse. I'm sorry.
Oh, sure.
Or page down.
I apologize.
I see. Okay.
Yeah.
Perfect. Hello, my name is Caroline Valdez, and this is.
And I'm Andy.
And we did our stats presentation on lo-fi music and its impact on productivity. Okay, and I know how to work it.
You should be able to just stick it
Oh, all right. What is lo-fi music? So lo-fi stands for low fidelity, meaning that the quality of the audio is imperfect and is often used as like background study music. So think about vinyl crackling, the sounds of a fireplace, rain, all of those nice soothing sounds layered on top of music.
Okay, so our experimental question for this project was, is it more productive to do tasks with lo-fi music or without lo-fi music? Yeah. So our first research, so what we did first was we basically printed out 2 third grade math worksheets. They were both very different, but like the same like content, yeah, difficulty. And then we later labeled them A, the first worksheet, and then B. A would be the one with music, or B would be the one without music, right? We then gave the participants worksheets in randomized order, and we did one worksheet with lo-fi music and one without it.
Yes, and then we looked to see how many math problems were finished in 1 minute, and then we analyzed that data. Wow, our slides are kind of messed up. Okay, so our hypothesis testing, for our null hypothesis, it was that the difference would be equal to 0. The alternative hypothesis, which is that the long-term difference would not be equal to 0. All right, for this study, we had 20 participants. The difference in our mean was 0.9 seconds, and our standard deviation was 4.43 seconds.
Oh, so that would come down to our t-stat being 0.928, and our p-value would be negative 0.2.
All right, to reject or not to reject, that is the question. So given that the p-value is greater than 0.2, there's no reason to reject the null hypothesis of that the difference is equal to 0, so we accept that null hypothesis.
And then our CI, which is our confidence interval, was -1 and 2.8, which our CI covers 0, which further emphasizes the fact that there is no statistical difference between playing lo-fi and just sitting in silence productively.
And that's for a 95% confidence interval. All right, for our validity conditions, we did have 20 differences. So that was one of the validity conditions that we were able to fulfill. And our data, as you can see, is not too skewed. We have a nice large peak in the middle, and it kind of tapers off to the sides. All right, so there was not random sampling. We actually mostly we chose our friends. I asked my family and even one of my professors because we were in kind of a pinch. So there's no random sampling. However, there was random assignment. So we just randomly chose whether this person would get the lo-fi first or not and which test they would get first. So because was an experiment, we are able to make causation claims that there is no causation between one or the other. There's no impact, but we cannot generalize this to a larger group of people because there was that lack of random sampling. Thank you.
Any questions?
So in like the very first slide, you mentioned that the difference between these was a measure of seconds, correct?
Yes.
So why was the decision made for this study to use seconds as a measure of success when you're completing an assignment? Is there a reason that you didn't choose like performance on it?
You know, that's a great point. It was a difference of performance. So seconds is wrong. It should be problems. You're correct.
Okay, thank you.
No, yeah, for sure.
Other questions? All right, let's thank our speakers again. All right, and for our next presentation, we will have Trevor, Eleanor, Reagan, and Eunice presenting on predicting house prices and glass types. Let's see. Oh, and he's got them right up there for you as one of the tabs.
Thank you.
Uh-huh.
Oh, okay. Well, real quick, I'm Reagan.
I'm Eleanor.
I'm Eunice. And then we also had another partner, Trevor, but he could not be here today. So to give a project overview, this is a project we did in Math 313, Statistics and Data Science. Take it. So we had two prediction model problems. One was a regression model where we were predicting house prices on a data set. And then a classification problem where we're predicting the type of glass given these variables. And so then for each problem, we were required to build and compare at least 3 different models and then use performance metrics to compare them, and then to submit a final model for each of those data sets to then be submitted for like a little competition. So whichever group in class had the best predictive performance models for each of these data sets earned extra credit. So yay.
So the metrics we used were MSE and misclassification rate because we had one categorical problem and one quantitative prediction problem. So for the quantitative one, we used MSE, which measures the average squared difference between predicted and true values. And this is used to evaluate regression performance, and a lower MSE usually means a better model. And for misclassification rate, it's the proportion of incorrect predictions over total predictions. And this is used to evaluate classification performance, and the lower classification rate usually also means a better model. So for the quantitative problem, we were given a data set containing information about houses, and our task was to come up with at least 3 different models to predict the quantitative house price. And then we had to determine which model had the most accuracy in predicting the prices, and we submitted in our best model to be tested on the unseen test data set. And on the left, you can see a sample of how the data set looked like and what variables were in there. So Eunice and I worked on coming up with methods for this model. We used the divide and conquer strategy to approach this problem, and we came up with 5 different models in total. So first off, we started off by splitting the data set into a training set and a test set, and then creating a fixed set of faults to ensure consistent and comparable results throughout our models.
And then we trained each model on the training set and then used it to predict it on the test set. And then from there, we calculated the MSE and chose the model that resulted in the lowest MSE. And on the left, you can see like a little code sample that we did R of how we split the data sets and into the test and the training, and how we also created the fault numbers. So these were the 5 models we came up with. The first one was Elastic Net, and it's basically a regression model that combines dependencies of lasso and rich regression, which allows shrinkage of less important features while ensuring important information is still kept. And then we also did bagging, a technique that combines and averages multiple models trained over different bootstrap samples of the training data. And this reduces variance and overfitting and improves predictive performance. We also did random forest, which is an extension of bagging, but considers a random sample of predictors when splitting the tree, thus decorrelating the trees. And then we also did KNN regression, which is a non-parametric method that predicts a value by averaging the target values of the k closest data points in the feature space. And for our last model, we did gradient boosting, an example technique, and an ensemble technique that builds models sequentially, where each new model learns to correct the errors of the previous ones by optimizing a loss function via a gradient descent. And so our best model was using bagging, which resulted in the lowest MSE among all the models. So we submitted this to be used to predict on the test set. And the MSE for our model on the unseen test data set was, you can see that big number. And then on the left side, you can see all the other MSEs we got from each model. And bagging was the lowest of all the models.
Now for the categorical problem with glass types. So we were given a data set containing properties of glass like magnesium, silicon, potassium, all that fun stuff. And then we had to make 3 different models, like we said, to predict the glass type based on these properties. And then compare that misclassification rate, which is that metric for comparison. And then, as you can see, like on the right side, like that's the data that we were given, and those are the variables we know to exist. And then we had to predict on the class attribute, which is the type of glass. So how we did this was Trevor and I each took 2 models, and we started by like splitting into training and testing, just like how Eleanor described, and you can kind of see how we did that with our code on the right. And then it's basically the same thing. And then these are the models that we did for the data set. So we did Elastic Net, which is like, it combines lasso and then ridge regression, so it kind of like minimizes shrinking and then also like doesn't just drop coefficients. So it's kind of like a balance of these. And then gradient boosting, where it's like each new tree you're like correcting as you go further down. And then random forest, we tried it like with just like bagging and then bagging with fewer trees and then a random subset of predictors. And we already talked about it, but and then KNN is like those K nearest neighbors. That's what the KNN stands for. And so our results is our best model for this data set was random forest with bagging, where M equals predictors, which resulted in the lowest misclassification rate on our training. And you can see our misclassification rate was 16.7% on the training data, and that is what we submitted, and it was good.
So next I'll talk about some challenges we faced in our project. The first challenge is the model selection and comparison. We had many different models to choose from, and it was not easy to decide which model was suitable for each prediction problems, and each model has its own strengths. So we took some time to compare them. The second challenge was ensuring fair evaluation. To make the comparison fair, all model has to be trained on the same data. We needed to decide on a fixed training set and test set, and also use the same cross-validation folds for each prediction problems. And here are some other models that we considered during our project. The first one is Lasso, which is a linear regression model that adds a penalty to the coefficients. The penalty can shrink some coefficient towards 0, which helps reduce overfitting and makes the model simpler. The second one is XGBoost. It has a higher performance implementation of gradient boosted decision trees. It builds trees step by step, and each of them, each new tree focuses on correcting the error made by the previous ones. And the third one is generalized linear model. We also call it GLM. It is an extension of linear regression that allows the response variable to follow non-normal distributions. It includes random component, systematic components, and link functions such as logit or log. And these models gave us more options and helped us better understand different approaches to predictions. And that's all. Thank you guys for listening.
Thank you.
Are there any questions? All right, thank you. All right, and our next speakers are speaking on the safety net effect predicting movie revenue by Evelyn, Laurel, Nigon, and Jessa.
Yep. I'm Jessa Swinehart.
Oh, well, we were introduced already, so let's get into it.
Okay, yeah. So today we're going to be looking at the film industry, and what we wanted to look at in this was if having a major distributor attached to a movie name, like Disney or Warner Bros., predicted higher box office revenue. So, and that's considering that top actors, top directors, top producers are controlled along with budget. And what we hypothesized is that major distributors would have more successful movies.
So in our data set, we ended up using publicly available data from Kaggle datasets, and which had to be normalized with some inflation adjustment. However, when our first plots came out, the problem that was very quickly noticed was that we had an extreme heteroscedasticity problem. And it took a little bit of time to figure out why. And the ultimate result of why was that I found a large number of highly erroneous data values inside of our data set. We had a lot of things, especially for indie films, because we included both major production films and independent filmmakings that appeared to not have data on revenue or budget, which was seriously impacting our model. And so using a bit of logging and a bit of intentional cleaning of our data, we got something that was much tighter and ended up being useful for our future analysis.
Then once we had all our data together, we moved into variable selection. So we started by running a regression with all of the data we had just to see what happened. And then we needed to cut it down based on what was and wasn't statistically significant. The first thing we looked at was genres. There were a lot of genres. Most of them weren't actually statistically significant, but we figured since they were a group, we needed to test them as a group. So we did a joint F test and found that as a group, as a whole, they were actually very statistically significant, so we left them in the model. And we looked at directors, which surprisingly weren't statistically significant. We think that might be because there's a collinearity between directors and budget, or a correlation between directors and budget, but we didn't actually look into that because that wasn't in the scope of our research question, and we just eliminated directors. Then we looked at season and horror interactions. We theorized that there might have been a horror movie that was released around the time of like Halloween might have been more successful than a horror movie released at some other time of the year. And it turns out that while that was true, that was the only season that was statistically significant, that had a statistically significant interaction there, and all the other ones didn't matter. So we ended up eliminating them. Well, we eliminated the interactions. We left both season and the genre of horror in our data set. Then we had popularity and vote average. These two variables were actually very statistically significant, but I did some digging and they come from the website that our data was originally pulled from. They're generated by users, which happens after a movie has come out. So they're not actually a useful predictor of the success of a movie before the movie is released. So we removed them.
And then finally, release year was no longer statistically significant, so we removed it. This left us with a final model that had the interaction of budget and distributor, as well as genre, runtime, season, and whether or not the movie contained a top 100 actor.
So here are some of our key findings. Our model fit, represented by our adjusted R-squared value, explains about 39.3% of the revenue. Our first key finding is what we term the safety net effect. This is shown by the intercept difference of the major studios and the indie studio movies. The coefficient is a positive 1.63, which then translates to that with the constant budget, simply a movie simply being distributed by a major studio increases the baseline revenue by around 400%. The second thing we found was a diminishing returns effect. This is shown by the interaction, which had a coefficient that was negative and highly statistically significant. You can see that on the plot, the red line represents the indie studios. We can see that it's steeper, which means that for each dollar spent, the increase in budget was greater. Whereas if you look at the movies released by the major studios, you can see that it's a much flatter line. And this is explained by how the movies start with a massive budget, so that then results in the revenue diminishing as the budgets increase. And then here are some other things, other variables that were statistically significant in our analysis. Budget was the strongest predictor with the lowest p-value. Second was star power. This is whether the movie had a top 100 actor in them. It showed that it positively increased the budget, the revenue by a lot. Next was an effect of seasonality. We found that generally movies released in spring and summer performed way better than movies that were released in fall and winter. And lastly, we looked at some genres and we found that family and animation movies are usually positive drivers of revenue, whereas documentaries resulted in negative revenues.
So the core question of our project is the idea of Disney magic, of does having a big producer with a big studio and a lot of money make good movies? And our conclusion is yes, we do believe in the Disney magic. All of the fairies get to live. Tinkerbell will be so happy. But it works differently than what we expected. Our initial prediction was that the scaling of talented directors in big studios and large budgets would be much greater than that of independent films, and it turned out to be the opposite. The effect that a big studio gives you is a safe baseline audience, not return on investment, which was surprising to us. The reality with indie films is that they are very high risk, but very high reward. There's plenty of indie films that have very small budgets, but they can get pretty decent box office revenue. And the biggest thing from our study was that small increases in budget result in much more substantial increases in both likelihood of that film to succeed, of an independent film, and the revenue that that film will achieve. However, there were some very significant limitations to our study. In addition to the culling of our own data set and the fact that indie films which do not make it to the theaters were almost certainly not recorded, we have a really strong survivorship bias that was very hard to account for. In addition to that, we lack some of the information on marketing or other promotional things that large studios do to make their movies more attractive. That was not included in our data set, and we were not able to effectively include that information with the several thousand results that we have. So we had to forego that. And that is likely a big impact on the baseline audience of some of these major films, which we were not able to account for. So in conclusion, we do believe in Disney magic, but it's not how we think. Do you have any questions?
I have a question for you. Would you expand on survivorship bias?
Yeah.
Did I get that right?
So, like as a concept or in our?
No, as a concept, I'm not quite sure I understand what you mean there.
So survivorship bias, my favorite story of survivorship bias goes back to World War II airplanes. And there was a study done on airplanes in the British Air Corps. saying, where do we need to armor our airplanes? And so ground crews took note of all of the bullet holes inside of the airplanes when they flew back and landed. And the generals got together and they said, hey, we should reinforce these areas that are shot up. And one of the chief engineers said, no, you need to reinforce the areas where they're not shot up, because you don't get to look at the bullet holes of planes that didn't make it back to base. And so we have a similar problem here. We don't get to see the result of indie films, which were never even released to the public. There's probably a large number of those films which did have budget, did have revenue, but didn't have any revenue because they were never released. And so we can't account for that since there's no way to find it.
Any other questions?
First of all, great presentation. My question is, with what was the data set, or how many movies did you look at?
So it was a publicly available data set that we found on Kaggle. It had 5,000 movies in it originally. After the data trimming that we did, it ended up being around, I believe, 3,200. So we had a very large sample size. It was a mix of independent and major films, and it dated back from, I believe, like 1960 or 50 all the way up to like 2023, 2024.
Any other questions? Let's thank our speakers. All right, next we have Carly, Olivia, Abby, and Heidi presenting perception of duck versus rabbit image association with dominant ant.
All right, so before we begin and introduce ourselves, we'd like to get a show of hands on who sees a duck first in this image and who sees a rabbit. All right,
I'm Olivia. I'm Carly.
I'm Heidi. And I'm Abby.
And for our Math 115 final project, we decided to look at the perception of the duck versus rabbit image that you just saw with its association with your dominant hand.
So for our research question, we decided to ask, does handedness affect what your brain perceives first in the duck rabbit image?
So image illusions like this one, the duck rabbit, are used in psychology to study how people interpret visual information. Images contain two possible interpretations, and your brain must decide which one to perceive first. Researchers have been interested in factors that could influence this perception, including handedness, and that is why we chose it for our project.
For our study design, we did an observational study. We sent out a survey from the material convenience sample with email list that Professor Wood provided to us. Our participants included students from Math 115 to 19, along with the women's softball team here at home. And then both of our variables were categorical. Our independent being handedness, if you're left or right-handed, and our dependent being which animals you first in the image, if it was duck or rabbit. And then on the right here, we just have an example of what our survey looked like. We asked 2 questions, and then this was the image shown to participants. So for our data analysis, we decided to do frequency tables for dominant hand and percentage of what picture was seen first. We also did a contingency table to compare the variables that's seen on the next slide. And finally, we did bar charts. So this bar chart on the right reveals that 19.4% of the participants were left-handed and 80.6% of participants were right-handed. And then the bar chart on the left reveals that 20.8% of participants saw a rabbit first and 79.2% of participants saw duck first.
So for our procedure, like stated previously, we sent the survey out to a list of students, and then once all those surveys came back, we compiled the data and then used Jamovi for our statistical analysis. We ran a permutation test simulating the null hypothesis, and then our result was an observed difference in proportions of people who saw the duck, righties versus lefties, which gave us a value of 0.0961. This basically just means that there was a higher proportion of right-handed people than left-handed people that saw the duck because that value is positive. And then our null hypothesis was handedness is not associated with the image perceived, and our alternative hypothesis is that handedness and the image perceived are associated.
So for results, we simulated a normal distribution using 8,000 simulated simulations.
That red dotted line is our observed difference. That's what we saw in our data. It's right in line with what we would expect to see if there was no difference between the two. We got a p-value of 0.642, and this just goes to show that there's no evidence of a difference in duck rabbit perception and handedness of the individual.
So our limitations that we found in our study, we had fewer left-handed participants than right-handed participants. Our survey was also sent out by email, and many students might not look at the email or even open it. So our results cannot be generalized to the public or to Hope students because it was a convenient sample that only included Hope students, and it was a younger age group. So, and our sample size was also very small. So if we had a bigger sample size, it may have allowed us to detect a difference if there was one. In conclusion, our p-value was above the significance level of a 0.05. In that case, we failed to reject the null hypothesis, and we find no evidence that there is an association between handedness and the initial perception of the image. Thank you.
So you found some literature that said that the handedness and the viewing of the duck versus the rabbit was existed. And you've seen evidence of that in the literature. Did I hear that right?
I think it was more like, can you go back to that slide? Yeah. Kind of like left-handed versus right-handed people. You always hear like, oh, like if you're left-handed, your left or right brain. I don't know exactly what one it is. So we kind of like took that idea and was basically like,
Gotcha.
you know, like, does your dominant hand
Sure.
basically like impact what
That
you
makes
see
sense.
first?
I just wondered if there was already some out there.
Not that we found.
Any other questions? All right, let's thank her. And our final presentation this afternoon is by Kate and Isaac, and they're presenting on college majors analysis. So Elam is part of their group, but wasn't able to join us today.
Yeah. Well, guys, my name's Isaac.
I'm Kate.
We did,
Oh, sorry. 11's not with us.
yep. We did our project in 2019 on analyzing college majors. So for our introduction here, our topic of interest was predicting success post-graduation based on the major you selected and your gender. The big significance of this is obviously impacts your career choices in college, promote certain recommendations that your college might promote to you when you're first coming in an undeclared major, and also influences like the relationships you'll make when you choose a major and interact with people in that major.
So our data was taken from the website called 538.com, which does all kinds of statistical projects like this. But we just took their raw data set that they had used, which came from the American Community Survey from 2010 to 2012, which is like a public use microdata. I don't know. It's free, available from the government. Doesn't matter. But each row in this data set represented a major with 173 total majors represented. And then many people were sampled per major, totaling 6.7 million people across all of the majors. And then, oh, go back one. We selected to focus on the variables major category, share women, unemployment rate, and then the median salary. So we started by data filtering and doing some mutation. So all of the data was filtered to drop any rows that were missing values, which I actually don't think there were any, but just in case. And then we mutated the variable share women to add a new variable of gender dominance to change it from numerical to categorical, so we could run our ANOVA analysis easier. So if the major contained greater than 50% of female graduates, it was deemed a female dominant major, and otherwise it was a male dominant major. So our first question was, do major and gender impact employment rate? So our null hypothesis was that there is no impact on employment rate after graduation, and our alternative was that there is an impact. So first we constructed a box plot to represent unemployment rate by major category, just so we could see what the data looked like. And then we also did a box plot of unemployment rate by gender. And you can see those on the side there. And then we ran a two-way ANOVA test on how gender and major category impact unemployment rate.
You can see our code if that's interesting to you. So overall, we found that there is not a statistically significant difference in employment rate between male-dominated and female-dominated majors because our p-value was 0.9, which is really high. And then there is a statistically significant difference between employment rates and majors since the p-value was less than 0.5 or 0.05. As you can see, it was really small.
Okay, I'm on question 2. So for this question, our null hypothesis is gender and major do not impact your median salary after graduation. Our alternative hypothesis is that gender and major do impact how much you make coming out of college. Okay, so almost a identical graph, pretty much to the first question, was just changing the unemployment rate with median salary. So you have that same box plot for gender and a box plot for each major category, but this time detailing like the amount of median salary that they got. And the R code as well on the bottom. In terms of results, there is a statistically significant difference in median salary between male-dominated majors and female-dominated majors, since the p-value is really, really small. In terms of the major effect, it was also significant because the p-value was also really small in that one as well. In terms of like our further analysis, on the left are 2 images that detail the unemployment rates of the highest and the lowest majors. And then on the right details the pictures of average median in terms of salary between genders, and then the highest median salary for majors and the lowest median salary for majors as well. So on the left, you can see social sciences and law, arts, and unfortunately for me, computer science major. Stupid AI, but that's personally. You can see that they have the highest unemployment rate. And then engineering, biology, agriculture, surprisingly enough, and education have the lowest unemployment rate. In terms of like the median salary results that we got, top right image shows that males do tend to make more than females. And in the major categories, STEM and law and I guess business, I wasn't pretty surprised by that, make more money than poor psychology and other social science majors. Okay. In terms of overall conclusions, gender has a statistically significant effect on median salary, and major category has a statistically significant effect on both median salary and unemployment rate. In terms of like what we did for this project, we used an additive model for ANOVA. That way we tested for interaction to make sure that gender domination and our numerical variable did not interact with each other. They were not dependent on each other. Otherwise, we would have had to change our model. Also, Dr. Martin told us and recommended to us after we had finished our presentation that we could more accurately represent gender, perhaps. So instead of just making that cutoff at 50%, we could have split gender up into like 3 different groups. So if it was like higher than 60, then it would be female dominated. If it was lower than 40, then it was male dominated. And in the middle would be like neutrally dominated. So I guess we maybe didn't represent gender as accurately, even though like our results from how we represented it are valid. Thank you. Any questions?
Going back there?
When you listed gender, it seems to me that you defined gender based on field, correct? That it was like male dominated versus female dominated was about the field, not the individual, correct?
Correct.
Did you have data in the data set you had on individual being male or female?
We did not. The data set only includes a variable that's called shared women, which they, I guess, had already calculated across however many participants were in that major, what the share of women was.
That was my question. Any others? All right, let's thank the speakers again. All right, I just want to thank everybody for joining us for our stat showcase. We really appreciate your attendance. There are some goodies at the back. If you didn't find those already, please get one. If you're here for one of the upper level math classes and want community points, I think there's some line cards back there. So grab those. And thanks again. Have a great weekend.